In the circuit shown, the current in the 1 ohm resistor is, let me redraw the circuit, let me draw a zoomed in diagram. Okay, this is a 6 volt resistance, this is a 6 volt battery, there is a 3 ohm resistance, there is another 1 ohm resistance, and there is 2 ohm resistance over here, there is 9 volt battery, and this is a 3 ohm resistance. Okay, 9 volt battery, and this is 3 ohm resistance. Let me name the points. This point, let this point be A, this point be B, let this point be C, this is D, this is E, this is F over here. Let me consider two outgoing currents. This is I1 and this is I2. So the total incoming current at the junction B will be equal to I1 plus I2. Total incoming current is equal to total outgoing current. I am applying the Kirchhoff's current law over here. Okay. First I will apply for loop. In loop A, B, E, F, A, B, E, F, A, I will apply the loop over here. Okay. A to B, it is equal to negative 6 volts. Okay. And B to from B to C, B from B to E, I am going opposite to the direction of the current, so it will be equal to plus 1 into I1 plus I2. Okay. While going from E to F, I am going opposite to the direction of the current, so it will be equal to plus 3 into the current over here is equal to I1 will be equal to 0. Okay. So if I simplify the circuit, it will be equal to 4 I1 plus I2 will be equal to 6. Let this be equation number 1. Okay. Similarly, I will apply the Kirchhoff circuit law in loop B, C, D, E, B. Let me apply it in the loop B, C, D, E, B. B to C, it will be equal to positive since we are going, it will be negative since we are going in the direction of the current. It will be equal to negative, so it will be equal to negative 2 I2. Okay. While going from 9 volt to, we are going from positive to negative, so it will be equal to negative 9. Okay. So after that it will be equal to over here negative 9. Okay. While going from D to E, while going from D to E, it will be again equal to negative 3 I2. While going from E to B, we are going in the direction of the current, so this will be equal to negative 1 I1 plus I2 will be equal to 0. So basically over here I can say that negative 2 I2, negative 3 I2 and negative I2, okay, which is equal to negative 6 I2. Okay, it will be equal to negative I1 is equal to 9. Okay, let this be equation number 2. Okay, let this be equation number 2. Okay, so we have got two equations and there are two unknown. Okay, I will multiply the second equation, by 4. So I will get minus 24 I2 plus minus 4 I1 is equal to 36. Okay, is equal to 36 over here. When I add both of them, it will be equal to negative 23 I2 is equal to 42. So I2 will be equal to 42, negative 42 divided by 23. So I2 over here is equal to negative 42 divided by 23. So 4 I1 negative 42 divided by 23 is equal to 6 over here. 4 I1 over here will be equal to 6 plus 42 divided by 23. So so over here I1 will be equal to, I have to divide it by 4, it will be equal to 1.5 plus it will be equal to 1.5 plus it will be equal to 10.5. Okay, divided by 23. So 23 into 1.5, so 23 into 1.5 over here will be equal to 23 into 1.5 will be equal to 34.5. Okay, 34.5 plus 10.5 divided by 23. Okay, divided by 23, which is equal to over here, which is equal to 34.5 plus 10.5, which will be equal to 45 by 23. So the total current over here will be equal to I1 plus I2. When I add both of them, it will be equal to negative 42 divided by 23 plus 45 divided by 23, which is equal to 3 by 23. Okay, over here it will be equal to 3 by 23. Let us check the answer over here. So 3 by 23 will be equal to 0.13. It will be equal to 0.13. Okay, and since the current is positive, it will be going from E to B. In this case, in the given diagram, it will go from Q to P. Okay, so the current will be 0.13. okay, ampere, and it will go from Q to P, which is equal to option number A.